So these are the soil samples from the site. For easy access and working, I have packaged them per site, from site 1 up until site 8 to the other end. So I just take the bag I need and then to my workstation there. So now I'm basically busy weighing out things, drying, and then after drying, that is where most analysis will start. That will include your particle size, moisture, salinity, and then the blue carbon measurements. So now, since I'm starting, I'm mostly busy with weighing out and drying. So now we're basically doing with the sediment moisture analysis. So for the sediment moisture, basically we're doing according to this, is it Gardner? I'm not sure, but you weigh out 10 grams of your weight of your sediments, and then you dry those ones in the oven for 60 degrees for 48 hours. However, you do that using crucibles, and then you need to first measure your crucible weight. So this is what we're doing for right now. As we see, here's our crucible weight, and then we've written it down here. So now we add 10 grams to make it for the wet weight, and then we'll put in the oven. All right. So you see the crucible weight was around 24, and now we've added our 10 grams. We're now sitting at 34. We're just putting it a little bit above just to be safe, but it's 10 grams. We're using this scale with the 4-digit one because it's the more accurate one to do this kind of calculation. So this one is for the sediment moisture. We'll now, after we're done, dry it in the oven, and then after drying, we basically use the calculation for sediment moisture, and we'll be done. So basically, this is the oven we're using for the sediment moisture, the one we put in yesterday. They're running at 60 degrees, and then they're gonna run for 48 hours. This is the ashing furnace that we use for the organic content. It's at 550 degrees, so the crucibles are in here, and then it's left for like 8 hours. So currently this one, it uses the Fahrenheit system, so but this is more or less 550 degrees Celsius, because 550 degrees is more like 1022 Fahrenheit. So once the 8 hours is over, then we're gonna leave it to cool, and then reweigh it, and then the equation will be used to calculate the organic content. So these are now the crucibles from the ashing furnace. They baked now after they are 8 hours at 550 degrees Celsius. So we're now gonna reweigh them to get the weight after ashing. That will enable us to be then be able to calculate organic content or organic matter. So now what I think it's advisable that we do, when you put the thing in the furnace, it's gonna, the marker, even though it's a permanent marker, it dies off at a very high temperature. So we might end up not knowing which sites are which ones in the crucible. So you create some form of a mind map, a reminder for yourself that this is how you've put your crucibles into the ashing furnace. And also when you arrange them in your boxes, you should arrange them in a way that you have clear labels that this is this side, this is this side. Because the labels, when you are using the permanent marker, it dies off in the ashing furnace at a very high temperature. So this is what we've done here. So we're now gonna weigh these ones and then get the reading. Alright, so these ones here, we're busy with particle size analysis. We're doing our particle size analysis using the hydrometer method. So now for the hydrometer method, we need about 40 grams of dried sediment into those cylinders. So this is the drying process. Now I'm weighing at just about 50 grams, so that once the sediment is dried, we get the 40 grams, mix it with the sodium hexametaphosphate, and then we conduct our hydrometer. So these ones will go into the oven at 105 degrees for 24 hours, and then take our 40 grams for the particle size analysis.
We are measuring sodium hexametaphosphate to prepare this with distilled water overnight, and then tomorrow this distilled water, this solution will be added with distilled water to be added to our sediment samples. We have our samples that have just come out of the oven, and we are busy measuring exactly 40 grams, which is going to be mixed with our solution and put on the shaker overnight.
So now this is a solution that was left overnight for it to dissolve and stir so that it becomes an actual solution. So now we're adding it into the beakers with the actual sediment, the 40 grams that we're gonna do the particle size with. So now we're gonna weigh, we're gonna put in 100 ml of the solution together with 250 ml of the distilled water, leave it on the shaker overnight so that it does its thing and stir, and then tomorrow we do the hydrometer, we take the hydrometer readings. So this is now the hydrometer method. So we just added the solution that was left overnight in the beakers. We filled them up until the 1000 millimeter mark, and now we're gonna take our hydrometer reading. So now, just to make sure everything is mixed properly, we first have to shake this thing inside the cylinder up until you see everything mixed thoroughly. See? There you go. And then soon after mixing, I'll put it down, put in the hydrometer, take readings at 30 seconds, 60 seconds, 3 minutes, 1.5 hours, and then at 24 hours. That is basically our hydrometer method. This is the hydrometer. So soon after shaking, I'll put this one in and then take the readings at the different time intervals. So these are the sites, 24 samples and 1 blank solution. The blank solution is basically like the control, which is sitting over here. So this is basically the hydrometer method, and then once you start measuring, we just put this in and then take the reading from this thing. Alright, so these ones are for the bulk density. So now, but the plan is to use the elemental analyzer to calculate for us organic carbon, because that is the most accurate way. So that's why we needed to collect these bottles. And this here, what we have is 50 mils of a syringe. We needed to have 50 mils so that we have a constant volume, because the formula for bulk density is the dry weight divided by the volume of whatever you collected your sample with. So our volume there is the 50 mils. So basically we just need to dry this and then get our dry weight, and then basically plug into our formula. So we'll just transfer this to a beaker, since we know we can't put the plastic bottles into the oven, and then just wait for our dry weight for the bulk density. Right, so now we're busy doing the salinity analysis method. So for this method, what we need, we take 250 grams of the air-dried sediment. We mix it with the distilled water up until it forms a saturated paste, and then leave that overnight. And then the following day, we're gonna filter through and then measure the salinity from the filtrate using a probe, and handheld probe. I just put in the drop of the filtrate, and then it will give me the salinity reading. So now we're just creating the paste. Tomorrow we'll filter through and then get the salinity reading. That's it. Okay, it's basically putting this in just to make sure it's tight enough to assist in the sucking out of the air. It needs to be tight. And now we're gonna pour in our sediment. So these are basically the two instruments I'm using for the salinity readings. Actually, this is the main one, because this is the nice thing about this one is that it actually gives me a reading. But then I use both of them just to check whether am I getting the same readings, to validate the readings I'm getting. So this one, I think I've explained before, you just put your drop of your filtrate and then you read, it gives you a salinity reading. And then this one is also a refractometer. You also put a drop of your filtrate here, and then you look through, and then you'll see where the blue line is where you take the reading. That's basically your salinity readings. We filter through our sediment from the paste from yesterday, and then we're using our handheld probe to measure salinity, and there we have our reading for our sample, which is 58 parts per thousand. Yes.